This is expressed in at high concentration in newborn babies. The reason for this is when the newborn comes out of mother's womb, these babies, they come into colder temperatures because mother's womb body temperature is 37 degrees centigrade and outside temperature is 25 degrees centigrade, right? So that means almost like 12 degree minus 12 kind of thing for the baby, right? Getting into colder temperature. So until the newborn get used to this new world, right? So newborn has to maintain the body temperature because there is no connection right now. Like once the birth happens, there is no umbilical cord cut, separated from the mother. So baby has to take care of himself or herself own. Although mother will help you, will like keep the baby warm, all that. But inside the cell, you got to increase the temperature. So the baby has to take care of herself or himself, right? So one of the way to do that, the nature, the God created that way, a brown adipose tissue, which has higher thermogenins, higher expression of this protein UCP1, more in their mitochondria. And that means they burn a lot of food to generate heat and get used to the new world. That's why what is the job of baby? Newborn baby, what is the job? Baby has only one job, to eat, sleep, eat, sleep, eat, sleep, eat, sleep. That's it. You have not seen, you have seen like, I'm not sure, your own baby or your sister, brother, relatives, small babies. Most of the time they are, whenever you go sleeping, you want to go and see baby and, hold, play, always sleeping. Why? Because that's the job of baby. Eat, sleep, eat, sleep. So only purpose is to maintain the body temperature. Lot of food baby eats, right? So as they get used to, thermogenin expression slowly decreases. The UCP1 expression slowly, number of UCPs expressed in the mitochondria slowly decreases because you are getting used to this new world. So when there is higher thermogen and that type of heat generation using this thermogenin, where you are catabolizing a food and allowing free flow of protons and releasing heat, is called as non-shivering thermogenesis. You don't shiver to generate temperature. You don't shiver here, non-shivering. Generally what happens when we lose body temperature, we shiver a little bit. This happens when you're suddenly exposed to cold, you start shivering a little bit. And that is called shivering thermogenesis. Your skeletal muscle contracts and generate heat as a response to the cold, right? Here, there is no shivering, but there is increase in body temperature through thermogenin as a uncoupler. Okay, so when we exposed to the cold temperature, even right now, if you have couple of thermogenins, UCP1 here and there, what is the mechanism? And including newborn. So when we exposed to cold temperature, there is a sympathetic nervous system activation. Norepinephrine is released as a neurotransmitter, and that norepinephrine will go and bind to beta-3 adrenergic receptor. Make sure you remember this. It's more of physiology, but it can be asked in physiology, not necessarily in biochemistry. Which receptor? B3, thermogenin B3 adrenergic receptor. Okay, and in response to that, what happens? As it is shown there, so there will be breakdown of triglycerides in the adipose tissue. Of course, there are enzymes involved. We will get into that later. And that triglyceride breakdown releases fatty acid. And that fatty acid, what it does, it will go and open a pore in the thermogenin. Thermogenin has got a pore, ionophore. It opens the pore. As it opens the pore, your protons start flowing back into the matrix from the intermembrane space and thereby release heat. So fatty acid acts as a positive modulator of your UCP1, that is thermogenin, and open the pore, positive, and thereby generate heat. Okay, and that's the mechanism. And your T3, T4, it helps in this process. It positively helps in this process. T3, T4 works positively in activation of sympathetic nerves especially through beta-3 adrenergic receptor. That's how you got to connect T3, T4 with beta-3 adrenergic receptor in the brown adipose tissue. That is where is the connection. Okay, especially with the uncoupling proteins there. All right. So when this pore will be closed? Okay, now you have opened the pore. Pore is opened. When it will be closed? Can you just keep it open? Then how your newborn or whatever the cell which has opened it, how it will generate ATPs? Because we know that, right? When you open the pore, uncoupling going on, ADP will be more, ATP will be less. ATP is less, ADP will build up. And that's how you are increasing the body temperature. How long? Like cell will fail if you don't make ATPs. It has to make ATPs, right? Eventually. So that means there will be closure of this pore. You can also close it. Whatever is open, you can close it, thereby make your electron transport chain more efficient. How do you do that? When it happens, whenever there will be super higher buildup of ADP, because when you open the pore, ADP builds up. When it becomes so much, when your ADP increase so much, ATP is totally down, where it becomes cell to kind of, survival becomes a question. At that time, that ADP which is built up will go and inhibit, means close this pore. This pore will be closed by ADP. ADP, what I will write it is, here is ADP and GDP. ADP and GDP will close, negative, close the pore. Fatty acid is positively working on thermogenin and open the pore, whereas ADP and GDP, whenever they are in excess concentration, they simply close the pore and then make electron transport chain efficient. So like this, alternatively, when there is a need for heat, pore is opened through this beta-3 adrenergic receptor. When there is super buildup of ADP and GDP, lack of energy, pore is closed again, on and off.